This conference will now be recorded.
Yeah, very good morning to everyone. Like today, we will start with other project. We'll start with controllers. Okay, like we'll be dealing with two projects in the controller. One is interrupt controller, another one is SPI control. Okay, uh, to going through this, to modeling, writing a design file or a test bench with this controller, first you should understand what is meant by this controller. So what is the use of this controller? How to use this? What is the use cases of this controller? We should study that. This is what exactly we did in the previous projects. What we did, right? If you talk about memory modeling, so we understand what is a memory, how to do the read operation, how to do the write operation, then how to write the test benches. When you're writing the test benches, you're writing the different test cases. Okay, and then after that, we started the before project. What is before? Where before is used? What are the types of before? How to write a program for synchronous before and asynchronous before? And then we understand how to write the test benches to that. Correct? Even in for Millet model and Moray model, FSM also, we understand the concept of what is a pattern detector, what pattern I have to detect, how to write the implicit model and explicit model. So this is what we did. Like here also, if you want to write a program, a long program for the interrupt controller or SPI controller, basically you should have found about what is this controller, what are the ports to this controller, how many ports are there, what are the ports are input ports, what are the ports are output ports, what is the use of this interrupt controller. Any good programmer, they should know the logical thinking of what are the ports are there, how to use all these ports. Then writing a verilog or system verilog program is easy. Once you know that the logical details about any controller or it may be the protocol also, whatever the protocol you study, you are going to study. The logical behavior of those protocol, if you know, then you can understand the Verilog programming, then you can write a design file and the test bench file. Okay, to start with the interrupt controller, what is the interrupt controller? Why interrupt controller is used, or where we are using, how we are using. So you should know basic idea about the protocol. What is meant by protocol, and what is the use of the protocol, and what are the types of protocols we have. Using that idea, you are going to you are going to understand about the interrupt controller. So first, what we will do, so we'll going to discuss about what is the protocol. We're learning about protocol, definition of the protocol. What is the general meaning of the protocol? Widely, what is the meaning of this nothing but protocol? Some guidelines you are giving. Guidelines, set of guidelines you are giving. Correct? If you go to the bank somewhere, if you go to the bank, you can't directly deposit amount to the depositor, right? So you'll be following the protocol, right? What protocol is? You are taking HLN, you are noting all the details, okay, you are filling all the details, then you are going to the counter, then you are issuing the form, then they will acknowledge that, then you can able to deposit the amount. These are guidelines to deposit the amount. Because in different organizations, they will follow the protocols, guidelines, right? As like that, we can't do anything, right? So we should follow some set of protocols. Here also, as a front-end engineer, so mainly various protocols, like low-end to the high-end protocols. High-end protocols, if we talk about PCI protocol, DDR3, DDR4 protocols, PCI protocols, low-end protocols like ABP protocol. These are the protocols. So this is what you are going to study in the system verilog and other courses. The projects you are going to deal with is nothing but what? Protocols. Okay. If you talk about software engineer, what is the role of the software engineer? You used to build a website, right? Front end or back end. To build any front end and back end, what you should have idea? you should have idea about the algorithm, how I should build. Then later they will decide whether I can use the Java programming or I can use the Python programming or I can use any other program. Thoroughly understanding of algorithm is required for the front-end engineers. Correct? So for a software engineer, algorithms are very important. Like protocols is very important for what? VLSI front-end engineers, domain engineers. We will be talking about more about what? Protocols. What is this protocol is? Basically, protocol is the backbone of any communication in any chip. It is like a data transfer. Protocols are a set of guidelines. Right? Protocols is a set of guidelines which tells how communication between the one component and another component, or you can call what? Master to the slave. It is a putting a what? Guidelines here. It is a guidelines. So based upon guidelines, you can communicate. Communication happens between the master to the slave component. Master to the slave component. In that one very basic protocol we will be discussing is nothing but ABB protocol. What is ABB protocol is nothing but the full form of this is nothing but Advanced Peripheral Bus Protocol. Now what is the protocol? What is the protocol? It is a guidelines. Where we can use these guidelines? Between any two components. Say for example, my laptop is connecting to the projector through the HDMI cable. Correct. Now data is transferred from where to where? Laptop to projector. So this is like if I'm taking laptop as a master, my projector is a slave. Now there is a what? Data transmission is happening. How this data transmission is happening? This happened to happen. This communication happens between master and the slave. We will fix the what? Guidelines. That guidelines is nothing but a what? Protocol. Based upon the guidelines, you are doing the what? Data transmission from one component to the another component, master to the slave. That guidelines we call it as a what? Protocol. It is set of guidelines, that's it. Protocol set of guidelines which tells how communication will happen. Wherever communication happens, not only your data is transferring from a laptop to the projector. If you talk about your mobile communication, you are sending the message, you are sending the voice, you are sending the multimedia signals. Where data communication happens between master to the slave, you are putting a what? Guidelines. That it is what? Protocol. There are many protocols are based upon the category. Low end to the high end performance, different protocols are there. Like ABP, AXI, I2C protocol, then UART protocol, then PCI protocol, double data rate protocol, DDR1, DDR2, DDR3, USB. Many protocols are there. Okay. So you should start with the interrupt controller. You should have one idea about what is a protocol. In that basic protocol, you should understand. Okay. So in that we are talking about ABP protocol. So all protocols they will notate in the short notation. ABP protocol, AXI protocol, so on. So what is the full form of this ABP protocol is nothing but it is Advanced Peripheral Bus Protocol. When you talk about the protocol, again there is a two. One is on-chip protocol and peripheral protocols. On-chip protocol and peripheral protocols. What is a on-chip protocol is this ABP is one of the on-chip protocol. On-chip protocol. What are the peripheral protocols? Outside the chip, what you are using, those we call it as what? Peripheral protocol. Suppose you are inserting a pen drive to the system. What is your peripheral component is? Pen drive, correct? So outside the chip you are using those protocols we call it as what? Peripheral protocols. On the chip protocols, what you are using is nothing but on-chip protocols. Okay. Suppose if I am connecting this HDMI cable, this is nothing but a projector is nothing but what now this peripheral. In my processor, in my laptop, I have a processor. Inside that, I have an on-chip protocols. You can understand. So now ABP is a what protocol it is? On-chip protocol. Peripheral protocols and on-chip protocols. So when you start discussing about any protocol, you should understand protocol-based system architecture and what are the components in the architecture. What are the features supported by the protocols? How handshaking works in the protocol? What is the timing diagram of the protocols? And different phase in the timing diagram. And then you should understand how to do write operation. Data communication means what? Write operation and what? Read operation, right? So how write and read transaction happen in the protocol, and what is the signals are using? What is signal decoding of the protocol is very important. If you know this, later you rethink that how to write verilog programming. As foundation, you should understand how it behaving. Based upon that behavior, you are going to write a verilog program. Did you understand? Now, what the protocol is? It is a set of guidelines for communication from what? Communication happens between two components, master and the slave. Correct. So when you talk about protocols, two types. One is on-chip protocol and peripheral. On-chip protocol, ABP is one of the example of on-chip protocol. You should understand that what are the protocols or on-chip protocols, what are the peripheral protocols. Now I am connecting the keyboard. Keyboard is an on-chip or peripheral. It is a peripheral, right? It is a peripheral. It is not on the chip, right? It is outside the chip. So that keyboard is a what? Peripheral. Do you understand the difference between the two? Now, let us dive into the ABP. What is ABP protocol? Okay. Anyway, in upcoming session, we will be dealing with many protocols, the system verilog, etc. Now, one basic thing you should know that you should know the idea about the ABP protocol, as I already mentioned. You know that what is a protocol is nothing but it is a set of lengths how the communication happens between the two components. One component is called as a master, another component is called as a slave. Between master and slave, how address space will happen, how data phase will happen, how response phase will be happen. Inter-neural protocol is nothing but what? It is a collection of signals, a set of signals, plus what? Guidelines. That is nothing but what? Protocol. If you look at the analogy as I already mentioned, right? If you want to do the cash deposit, what we do? Do we just drop the cash in the cashier cabin and coming out of the bank? No, right? So bank as a cash deposit protocol, fill the cash deposit slip, then name, you should fill the data, right? Name, account number, the denomination, number of 100, account. To go to the cash deposit. So in this, in response to this, we'll get acknowledgement data. All these data, we'll be getting what? Response. So similar to this analogy, we can go back for the cash withdrawal, correct? So to this cash withdrawal also same. So we just take out the cash from the desk and come out. No, right? Cash withdrawal protocol will be there. Like this, what is analogy for cash depositing and cash withdrawing? In every realistic communication protocol, which gives the guidelines on how various phases of the transfer should happen. It is going to fix the guidelines. Or do you understand the definition for the protocol? Is it clear? Now, what is this protocol? I said two types of protocols. Two types is nothing but what? On-chip communication protocol. Another one is peripheral communication protocols. If I talk about on-chip communication protocol, communication for the block on the chip. What is the communication happens? Communication happens on the chip. Those protocols we call it as what? On-chip protocols. Examples are like what? ABP, AXI, AHP, OCP, Wishbone protocol. So these are the protocols which we will be using for what? On-chip protocol. Means if you took the analogy, communication between what? Only to the what? Bank employees. Maybe that is concurrent execution or sequential execution. But communication will happen between what? Only to the bank employees. Those protocols we call it as what? On-chip protocols. Are you understanding the definition of this? What is the peripheral communication protocol? The communication for the blocks with the other blocks outside the chip. So these protocols we call it as peripheral communication protocols. Like example is your USB, then PCI, DDR, UFS, HDMI cable, VGA cable, SD card, correct, keyboard, etc. So these are the examples of what? Peripheral communication protocols. Did you understand? ABP is what protocol it is? It is on-chip. On-chip means what? Inside the communication happens inside the chip. That protocol we call it as a on-chip protocol. Is it clear? What are the examples for the peripheral protocol, communication protocols? Like USB, HDMI cable, correct? SD card, HDMI cable, VGA cable. These are the examples of what? Peripheral protocols, communication protocols. Then why do we need so many protocols? Why do we need so many protocols? If you now let us take why do we need it? Why do we need many protocols? Whether you suppose there was a Nokia phone 111100, whether we stick to only that. No, right? We updated. We come to the touch screen. Okay, touchpad, touch screen. Now we are using touch screen. Why we go with the other one? Because there extensively there is a more usage, correct? Less price, correct? More things you can do, high performance, correct? This is what protocols also their versions changing, upgrading. Protocols also like how your mobile operating system or any operating system is getting updated. Updated means what? What do you mean by updated means? Change means extra features will be added to the existing. Correct. Like why do we need so many protocols? First, we'll understand why do we need so many protocols. Why can't there be one on-chip protocol and one for the peripheral protocols? Means all these protocols will be differentiated. Means how they are differentiated is based upon the what? Performance. Based upon the what? Power consumption. Based upon the what? Price. More price means what? More complex and area. Correct? For any protocol, we can only get the best of two. If you take any protocol based upon your application, any protocol will get the best two. Out of these three, one you have to compromise. Correct? If you are compromising with the price, low performance. Correct? If you are not compromising with the what? High performance you want, then what you need to do? You should compromise for the what? Price. Did you understand? If you for any protocol, we can get the best of two people, and we have to compromise on the what? Third. Let us take this analogy. You'll understand. Now let us take ABP protocol. So ABP protocol, here we are listing out ABP, AH and AXI protocols, how they differ. So ABP protocol is one of the basic protocol. First protocol with the basic advanced peripheral bus protocol. This protocol is a low performance. Then what? Low power consumption, low price. You don't understand. And if you look at the AXI protocol, high performance, relatively what? Low power consumption. What you should compromise what? Price. If any protocol if you take, you have to compromise. You will get the two and one you should compromise. Correct. Then why we needed protocols? I mean, why you should go for with the different protocols? Why can't only one protocol? That is a question. Correct. Did you understand? Question is, so HB falls in between. So HB will falls in between this ABP and what? AX protocol. So let us take why only one protocol, why we go for the many protocols is, let us take this requirement. Given a requirement, how do we choose which protocol we should use? We should use. Based upon that, we need many protocols. Let us take an example. There is a three keyboard controller. Is there? Keyboard and keyboard will be having a what? Keyboard controller. Correct? Keyboard controller. Let us take this. For a keyboard, the performance is not a really important. How means? Let us take one stroke of the key is nothing but what? One byte. Suppose if I'm asking you for if I give 10 seconds, how many keystrokes you will do? How many letters can enter? If you do very best case, hardly you will be doing 1000 to 2000 keywords you can enter within the 10 seconds if you are doing very fast, best case. Correct? So here, one keystroke of the keyboard is nothing but 1 byte. So 1 byte is nothing but I can take 10,000 strokes of the keyboard, that is equivalent to what? 10 kb. So 10 kb transfer in the 10 minutes. Correct? 10 kb is transferred in the 10 minutes in the keyboard. It is okay, right? I don't have any issue. It is low performance. For the keyboard operation, I can go with what type of protocol? ABB protocol. Now let us see the USB transfer. USB, how data will be transferred in terms of what? Gigabytes. Whether I can go with this ABB protocol, which is a low performance. What I want to do in the USB transfer, multi-gigabit bytes per minute you need to transfer. So that we need a high performance protocol. Did you understand? For the keyboard controller, I can use what protocol? I can choose AVP protocol, which is what? Low performance. For the USB controller, I can go with what protocol is? High performance protocol. So, do you think that why we are not only relying on only one protocol, why you are going for other protocols? It is based upon the what? Performance. Correct? Now, keyboard, I can go with one protocol. AXA, ABK protocol. For USB controller, AXA protocol. Are you understand this? Now, keyboard controller should be using what? Keyboard protocol. Now, next question. Now we understand that this one. Why do we need so many protocols? Why do we need so many protocols? Means USB I need high speed, high performance protocol. For keyboard I need what? Low performance protocol. Now the question is, keyboard controller should be using keyboard protocol. Why it is required ABP protocol again? Keyboard should be having a keyboard protocol. Why it is required a ABP protocol? Why? Because keyboard controller, any controller, always requires two interfaces. One interface to connect to the with what? Processor, and rest of the system is connected. Two interfaces, one to the processor, another one is what? Rest of the system. So other interfaces to the connect with the keyboard panel. So user will enter the data on the keyboard panel and goes to the what? Keyboard controller, and keyboard controller buffers the data, and processor reads the data through the ABP interface. What the question is nothing but why keyboard controller requires ABP interface? Why can't we go for the keyboard protocol? Why we go for the ABP? Now this keyboard controller will interfacing what are the components? One to the what? Processor. One to the what? Other rest of the system. To communicate this, one to the processor and one to the what? Rest of the system, what I need here? I need a ABP. So here, the keyboard controller should be using keyboard protocol, but why we require the ABP protocol is keyboard controller or any controller, not only keyboard controller. If you take the USB controller. If you take SD card controller. If you take HDMI controller. Okay. If any controller always requires two interfaces. What is the one interface is? To connect with the what? Processor and what? Rest of the system. So other interface to connect with the keyboard panel. Correct? Keyboard panel, you can see. This is connecting into the what? keyboard panel. This is a keyboard panel. One interface to the keyboard panel, one is connecting into the what? Processor and the rest of the memory. Here, what I need, user will enter the data. Once I enter the data panel, data goes to the what? Here, if I press the, this is a keyboard, if I press the keys, this data goes where? Keyboard controller. Keyboard controller. And keyboard controller, what it will do? It buffers the data and processor reads this data through the what? The ABP protocol. Did you understand? That's why we need a what? ABP protocol in this exam. Have you understand this? So similarly, if you talk about USB controller, so what protocol I required? AXI protocol, which is what? High performance AXI interfaces to connect with the what? Processor, and USB interface to connect with the what? USB devices. Similarly, if there is a DDR controller is there, what I need to do? We'll use AXI. Since it requires the high throughput, we'll be going for the AXI protocol. So why not use the ABP or DDR for the DDR? Why we are not using for the ABP for the DDR? Low performance. Low performance, right? Where performance matters, we'll go for what? High-end protocols. So why not use the ABP for DDR for the USB? It will result in what? Low performance. So we will study the interrupt controller. Now, of course, we will be study what? SPI controller, like etc. watchdog, timers, I2C controller. All those designs will have what interfaces is. ABP to connect with the what? Connected with the processor. So if I'm talking about interrupt controller, I should idea about what? ABP protocol. Did you understand? This is a keyboard. We're talking about this keyboard controller. Now we are talking about what? Interrupt controller. What is the use of the interrupt controller? How interrupt controller will be used? If I'm using interrupt controller, I should use the protocol, right? I should use the protocol. How do you understand this? So like this is a one use case. USB requires AXI protocol, DDR requires AXI, not ABP protocol because of low performance. So all these interrupt controllers will be using a what? ABP interface protocol. So to use this ABP interface protocol in the interrupt controller, we should know the working operation of what? The timing. I said that any protocol, what do you need? Logical idea, how logical it is behaving. Okay, we should know the timing diagram. We should know what is the different phases it is going, address phase, data phase, okay, response phase, or action phase, or setup phase. These phases we should understand. Based upon using these phases only, you can be able to build the protocols. Are we clear? Now, this is the same extension to this. If suppose any protocol we take, there will be what components? Two components. One is what? Controller. Another one is what? Peripheral. So DDR requires what? DDR control and DDR peripherals means DDR memory, and DDR controller connects to the what? DDR memory using what? DDR interface protocol. DDR controller needs to connect with the processor inside the chip. It connects through what? It connects through using the AXI. Similarly, if I talk about PCI peripheral interface, what will be there? There will be peripheral controller. There will be what? Peripheral interface, PCI peripherals. PCI controller connects to the what? PCI EP using what? PCI interface protocol. And then the PCI controller needs to connect with the processor inside. Then what you need? It should connect using what? AXI protocol.
स्लेट पेन
You
लेके
understand?
दे दिया स्लेट पेन लेके गई थी
Are you clear? Any controller?
हाँ
What do you need?
हाँ
The controller and peripheral. If I want to connect to the processor, connect through what? products based upon
दिखा वीडियो
what
नंबर के ये तो
performance.
गई कौन ये थोड़ी
Some
लेके गई थी
cases I
सिर्फ
need a
स्लेट पे
low
लेके गई
performance
थी
protocols, I'll go with AVP protocol. Some cases I need high performance protocols, I'll go with what? AXI, ABB,
तो दिया
etc.
पैसा तो दिया है
protocols.
मैंने दे दिए
Are you understand?
5 रुपए दिए
10 रुपए सामान लेके 5 दिया
अरे 10 रुपए दिए हाँ दिए 10 रुपए
Now this is the questions you can do. Why any controller characterize the protocol in high performance or low performance based on how much data happens? How do you categorize the protocols? How do you categorize the protocols? How do you categorize the protocol? On-chip protocols and what? Peripheral communications. For any protocol, what are the two types of the components? Controller and peripheral. You don't understand. Now we'll understand that what are the different phases of the ABP protocol. Now, this is a brief detail about what is a protocol, what is on-chip protocol, what is the peripheral protocol, why do we need these protocols, how you can connect to the processor through these protocols, okay, and then based upon their performance and then power consumption and price, how you can select the low performance protocols and high performance. You can focus on ABP protocol. So any protocol you learn, what you need to do, you need to focus on the what is that protocol name is. Correct. If I talk about ABP protocol, its name is what advanced peripheral bus, and what type of protocol it is used to stay. ABP is what peripheral or on-chip protocol. On-chip protocol. So then we should understand what are the protocol and so what are the signals? This, except this P select and P error, memory, right? If you remove this, this is similar to reset. We are using what? Read data, correct? And then we are using correct. If read only doing the what? Read up. Then extra thing is nothing but what? P select, P error. So ABP modeling is almost by this means almost it is like a because we done memory extra signals P select and P error. Indicates here is nothing but ABP protocol. P means protocols. Protocol clock, protocol reset, correct? ABP protocol clock, protocol reset, protocol address data, W data, read data, P write, P enable, P select, P read, and P error. So you can categorize this into the different signals, right? What are the common signals? Clock and reset. Then what is data related signals? Address, W data, read data. Then what are the control signals? Select, enable, W write, correct? These are the control signals. So these signals are categorized into different common signals, then data related signals, then control signals. Here, P select, P enable, and P ready, I can take it as one signal. Control signals. What is a P select in ABP protocols tells that P select means what? If your master is connecting into the multiple slaves, let us consider your master is connecting into the multiple slaves. You have to select multiple out of multiple slaves. You need to select what? Only one. That will be decided by what? P select. Among the connected the slaves, which one is selected will be decided by what? P select. This terminology is very important. If you understand this, and then when you are writing a program, modeling the program, you can easily understand. What is the P select indicates here? If master is connecting into the multiple slaves, correct? So among the connected slaves, which one we need to select? Did you understand? What is P enable is? The P enable is I. One P enable is equal to 1 means what it tells. Master is issuing a valid request to the what? Slave. It is requesting to the slave, right requesting. Did you understand? What is P equal to 1? Now slave is telling that I am ready for completing the what? Transaction. This select signal is multiple. There is a multiple slaves connected. Multiple slaves among which one I am select. And then P in me, master is ready to for what? Valid transaction. Correct. And then P means what? Now slave is telling you, I'm ready, okay, ready for completing the what? Transaction. Did you understand? I think other things already you know. Why do we need a clock? Why do we need a reset? And this P address, W data, R data I can categorize into what? Data signals. And then this enable is required P write enable and read enable. Based upon enable you are writing the data. Then based upon read enable you are reading the data. Then you are defined the two for write one enable, for read one enable. If you remember the memory model, I can use here only one enable, right? If P write is equal to 1, I will do the write operation. P enable is equal to 0, read operation. The extra signals we are using is what? Is select and error. I think error also we used in the before we are using, not in memory. We are not using the memory, correct? So extra two, these are the two signals, P select and what? Ready is already we use, right? Ready signal will be used. Correct? P select, P enable, P ready. Did you understand and we need to classify the signals into the what? Control signals and what? Data signals. So how handshaking will be happening? When valid is equal to 1, correct? Ready is equal to 1. P enable and P ready should be high at what edge? Suppose you are designing always at the past edge of the clock. P enable and P ready should be high at the positive edge of the clock. Did you understand? This is handshaking. Then how transaction will happen? In ABB, transaction will happen. Is nothing but setup phase. Another one is nothing but access phase. Transaction will happen in two phases. One is what? Setup phase. Another one is access phase. Do you have any questions? Will be what is address is here? Okay, what is the use of the clock? Clock required for modeling the sequential circuit. What is the use of the reset? You are deciding if reset is equal to 0 only, I have to do write and read operation. If this is equal to deciding that all edge type what you are using is making to 0. What is address is for? Based upon that memory depth, right? Memory depth, you need addresses. For memory, you need addresses. And this is nothing but what? Write the data to the memory. Or data means what? The data from the memory. Then WP write means what? If write 1, write operation. If write 0, data operation. Then this is enable. So P enable is nothing but it is saying that to do the handshaking operation. I am ready. Master is telling that I am ready to do the valid transactions. And then these two signals. If this is not happen, I need to print the error. And then slave to indicate I am ready to do the transaction completion, then ready should be 1. So this is what for the handshaking, how handshaking will happen. Then how the transaction happens is two phases. One is setup phase, another one is access phase. What is the setup phase and access phase is? This is the one. This is my ABB master. How many slaves are there here? These slaves are connecting through what? ABB interconnect, right? through ABP interconnect, this slave to the ABP master. So T select is nothing but number 4, which one I need to select. T enable means master is telling that I'm ready to do the valid transaction. Then to receive this, slave should give the acknowledgement saying that the T ready is equal to 1 and you can complete the transaction. Correct. So for protocol based architecture, one master connecting into the what? Multiple slaves. Using what kind of interconnect? Using ABP interconnect. So component in the ABP architecture is one is master, one is ABP interconnect, another one is what? Multiple slaves. Then other terms we are using P reset, P address, P W data, write enable, P select, P ready, and P error. So P enable, P ready is for what operation? And second. So P enable is nothing but master is indicating to the slave I am giving valid information, and P ready means slave is indicating that I am ready to. If it is read request, I am ready to the what? Give the read data. If it is a write request, I am ready to accept the write data. What are the control signals here? P select, P enable, P ready, P write, indicate whether transaction is happening or not. Address data signals are what? What are the address signals? PW write data, read signals of the what? ABP protocol. You understand? So if ABP, there are three components, correct? ABP architecture. If you look at the ABP architecture, three components. What are the components? Master, interconnect, slaves. Correct. To select among which one is I need to select a slave, P select is to do handshacking, P enable and P ready. You understand? Now, how transaction will be happening? How transaction will be happening? Set up access and one is set up access, another one is what? Access. Setup mode and access mode. So how transaction will happen here? Master drives the P select. P select of what? 4-bit vector. Select a particular slave. 4-bit vector to the particular. How many slaves it is interconnected? 4. So master drives a P select 4-bit vector to select the particular slave. Then master they complete the transaction by driving the P enable is equal to what? 1. Slave should be what? Slave response by giving the ready of what? 1. If I am using P select is 40 could be 0010, which one it is selected? This one it is selected. Correct. This is for 0, 1, 2, 3. Now P select it. The slave will be selected. P select if I am 0, 0 it is selected. P select it is no, right? Why it is no valid? Multiple slaves will not among multiple to do the valid transaction. 100. This is nothing but illegal scenario. We can't select the multiple slaves at the one same time. Are you understand? So different futures ABP protocol supports. Those are single write and single read, and then wait states by the slaves. We'll see what is the wait states by the slave. Are you understanding up here how this transaction will happen from master to the slave? What are the different signals we are using here? Did you understand? Now we'll see what is the ABP timing diagram, how this read and write will be happening. So ABP is a synchronous protocol. What is mean by synchronous protocol? Synchronous protocol means only it is responding to the what? Positive edges or what? negative edges based upon the signals we are using here. So in the synchronous protocol, all the signal sampling happens at the watch, positive edge of the clock. Any changes in between the clock edges is what? It is not important. We always look forward for what? Positive edges. Correct. For ABP transaction to complete, what are the signals? I need to do ABP transaction I want to do from the master to the slave. What are the control signals I should keep? One is select. Which slave I need to select? T enable, T ready, T write, right? T write. These are the signals. Here data signals are what? T address, then T write, T select, T enable, then this is write data is a data signal, and this is nothing but what? Ready signal. Correct? Now for ABP transaction to complete, what are the signals we are using? T select, T enable, T ready, all should be equal to what? 1 at what edge? Pass edge. Now you can say at the time T0. Is it any signal is I here? This address, right is what? 0. T select is 0 means it is not selecting what? Any slave. T enable is what? 0. This is nothing but write data, data signal. So data signals are address and data signals are representing lines, two double lines. Okay, these control signals are representing what? Like a single line like this. Do you understand? Now, what is the ready signal here is nothing but 0. Is anything happening at the time t0? No. Now, can you observe a time t1 to do the ABP transaction to complete? What are the signals you should keep I? Select, enable, ready signal. Here, T write is what? 0. T select is what? 0. This T1, rising edge of the clock. T select is 0. And T ready is also 0. No transaction will happen here. Now coming to the time T2. Time T2, what happens here? Now P write is 1. P select is what? 1. Then, but P enable is what? 0. P ready is what? 0. Is the transaction will happen? No. Now, can you clearly observe at the time T3? At the clock, rising edge of this T3? It is happened, right? Here, what happened here? Right is what? 1. Right operation. Right is 1. Right is enabled. I is I. What about the P select is? Selected. And then enable is also 1. Then what happens here? P ready is 1. So that your right is happening. Did you understand? At the T4, anything is happening? No. Because the time P select is what? 0. P enable is 0. Even the P ready is also what? 0. There is no ABP transaction is completed at time T4. To do ABP transaction to complete, what are the control signals should be high? P select is high. P enable is equal to high. Then ready is equal to high. Then right enable is equal to. How do you understand these signals? Extra signal we are talking about is P select. One more extra signal is nothing but error. Still, in this, I am not writing the error here. Are you clear? How the transaction happening in the ABP? What other control signals should we keep high? Correct. The same thing we did here. Same one. Same explanation what will be done. So we have to only look at the what edges. Positive. Any changes here between the positive edges? The change will happen at the output. No, right? The synchronous protocol, it is synchronous with what? Positive edges, or you can design for what? Negative edges. Are you understanding? At time T0, what is P selected? 0. It indicates that when P is 0. Okay. Okay means there is no signal. Correct? At time T1, still what? P selected 0. Still is not targeting any slave. Other signals don't care means what? There is no significance. At time T2, P select is 1 at this time. What is P select is 1. What happens here? Master is indicating to the slave that I am doing a transaction to you. So I will samples this one. Right? Now P enable is equal to 1 says that what? Master is indicating to the target slave. I have valid transaction. Period is slave indicating that what? I am ready. We read the transaction. So we are seeing what? Asynchronous nature, asynchronous nature. Synchronous nature. So P enable is sampled by the slave asynchronously here. Hence it is responding by what? At T3. Because P enable is enabled where it is enabled. P enable is enabled after T3 only, right? Whenever raising edge comes. It is asynchronously happened, correct? Within the edges of the clock, it is changing. But this changes happening, affecting, is responding to the what edge? A time past edge, at time T3. Do you understand? Where 3T is the clock edge where all the transaction is completed. Or do you understand? Handshaking for the AVP transaction, for handshaking, what are the signals you should do? Be enable and be ready. Right? To do actions, what action is set up action and what? Set up mode and the access mode. So then you should check all the signals. How do you understand? This is a ABP timing diagram. Correct? Slave introduces, suppose slave can also introduce the wait signals. So what is wait signals signifies? It's saying that you can hold sometime, wait sometime. After that, we can do the valid transaction. So slave introduces the wait states by keeping the period of what? Is equal to 0. This is a one timing diagram we discussed here. I think you understand this timing diagram. Now this is regarding about the wait states. Slave introduces wait states by keeping the period is equal to 0 on the what? Required clock cycles. Ideally, P ready can become 1 by T3 itself. You can see this is my P ready. P ready. In previous case, ideally it was I in where? I in T3, so that transaction is happened at what? T3. Now in this case, P ready is made what? 0 at what time? T3. Hence it is waiting for how many states? See here, the transaction is happened at what time? T5. If you look at the T0, no select is 0, enable is 0, ready is 0. At T1, select is 0, enable 0, ready is 0. No, yeah, sorry, ready is 1. Ready is 1. But this is not enabled, you can't do the transaction, right? Now time T2, select is 1, but enable is 1. 0. Is the valid transaction will happen? Transaction will not happen. Now time T3, what happens? Select is 1, enable is 1, but what is the ready is? Now slave is keeping the what? It is making to wait. Keeping ready is equal to 1, 0. Again T4 any transaction will happen. Why? Because ready is 0. Now coming to this T5. Enable is 1, select is 1, ready is 1. So the transaction is happened here. Correct? Now the slave is keeping what? Keeping the delay of how many clocks? 2 clocks. So, but it is becoming at T5, 2 waits are there. This is one wait and this is one, another wait. So 5 wait states are introduced here. Why do we need to introduce the wait states? It indicates that if the FIFO is full, if you try to write it, it won't allow, right? Slave is busy. It is fill all this memory locations. It is asking that after this one, you can do the write operation. So that FIFO is full. If you try to write, it won't allow. It will make P ready to the one 0. Once FIFO has a space is available in FIFO, then it will make the one P ready is equal to. You don't understand what is the essential use of the weight? Yes. Is it clear? If FIFO is full, whether you start, you should pin the error, right? That will not happen to the FIFO. So that if FIFO having a space, then I can tell that you can, now I can make it appear ready to the one to the transaction. How do you understand these signals? What is the role of the weight signals? Clear? Now this is what all the signal descriptions here. Can you remember what are the signals we are using for the EVP? You can categorize it in three signals. One is common signals, data signals, and row signals. So P address, P W data, R data, P write is I can call it as what? Data. P address means what? What is P address is? Slave location where master wants to what? Access. PW data means what? The data master wants to write into the what? Slave. R data means what? The port through which master reads the data from the slave. Did you understand? Now what is this P write? It is used by the master to indicating whether it is doing the read operation or write operation. If write is equal to 1, write transaction. If write is equal to 0, read transaction. What is P error? Used by the slave to indicate the error condition. If P error is equal to 1, slave is indicating that there is a error behavior. Slave target location does not exist. What are the error it is going to print? Is if the slave location does not exist, then what is another error you can do? Slave power is down. We are trying to access. So there you can print the what? P error. So these are the indication of what? Slave behavior. The slave behavior for error 1 indicates that there is a error behavior to the slave. What is error behavior is nothing but one is target location does not exist. And then put the error is equal to. Then if the slave power is getting down, then we are trying to access to that. Then you can print the what? Error is equal to. What is the error is the input pin or output pin? Error is input or output pin. Then P write is input pin or output pin? Input pin. P enable is input pin or output pin? Read is input pin or output pin? Output pin. Now after categorizing the signals, then again you need to decide that what are the ports are input ports, what are the ports are output ports. Did you understand? C select is input or output? Input. Did you understand? Ready, and then what? R data, then error is the what ports are outputs. Is it clear? This is. So what are the handshaking signals in ABPs? P enable and P ready. How handshaking will happen? Master drives P select to what? Select the slave and P enable to 1. Issue to the valid transaction. Slave drives the P ready to 1 to indicating it is ready to respond. At any positive edge of the clock, if P select, P enable, P ready is equal to 1, then transaction will be complete. Did you understand this? Are you clear? This is a final timing diagrams with the two states. Slave is indicating with the what? Wait state. By looking at this, T not anything is happening? Any transaction? No. At T1, since P select is 0, no transaction. At T2, P enable is 0. At T3, T ready is 0. At T4, still it is 0. At T5, P select, P enable, P ready is 1. Therefore, what? Transaction will happen. Read operation is happen, then but wait is happen at what? 2 clock. How many clocks? 2 clock cycles. This is nothing but wait stage. Until that it is a period is one, it is ready to do. But what happens since locations is not available for the FIFO of the slave? What happens? It will give the indication of period is equal to 0. Are you understand this one? Now you can see to learn about the ABP. What are the ABP signal directions? Are? What is address direction is? Master to the slave. W data is master to the slave. R data is slave to the master. Correct? The slave to the master. Then P rate is master to the slave. P select is master to the slave. And P enable is input master to the slave. P ready is slave to the master. And P error is slave to the master. You should understand this. Did you understand? So likewise, you can follow the like AMBA specification. AMBA is nothing but it is a protocol. In this AMBA documentation, you'll be seeing all the documentation of other protocols like ABP, AXI, many protocol documentation. It is available in the Google. You can get it download. The specification of the ABP protocol. You'll be getting a PDF documentation. You can refer what are the signals are using in the ABP protocol. So the Google ABP protocol specification, you can download it. Like if you want to study other protocol, there are signals and specifications. It is available in the Google, like AXI protocol, AHV protocol, like many other protocols. By referring the documentation, you can know what are the signals are common signals, what are the data signals, what are the control signals. So which widely you can use in the protocols. Or you understand this ABP protocol? But we are not going to write the design and test bench to this. But these ports are using in where? Interrupt control. Later we will be looking at the protocols. When we start with them, we will be going to write the design and the test bench for the ABP protocols. But to understand the interrupt controller, you should know on-chip protocol operation. In that, we are one basic protocol we are talking about is ABP protocol, low performance protocol. You don't understand? So with this understanding of the different signals of ABP protocol, now we'll go with what is the controller. What is meant by interrupt controller? Where this interrupt controller is used? How it is used? Why to use the interrupt controller? What is the role of this interrupt controller?
Hello, sir.
Did you understand? Yeah, hello.
Hello. Sir, can you please explain
Yes, hello.
when
You are
exactly?
audible.
Sir, can you please explain when setup phase and access phase happen? In timing diagram, when setup
Yeah,
phase and
when the
access
access
phase happen?
space is happening here, see, when the complete setup time and access time is happening, we should do the handshaking protocol. To do the handshaking protocol, what we have to do? P enable is equal to 1 and P ready is equal to 1. To do the access operation, what are the signals we should see? What are the signals? P select, P enable, P ready. If these signals are 1, then I can go with 1. Access. Access mode is whether it is write mode or read mode. Setup time means this is the one before going to the one transaction. All this is nothing but what I can say. Setup time. To do the access code, 3 pins should be high. Here I am setting up in few cases I am setting up 2, 1 and 1, 0. So the transaction is not happening. Correct. So if all these 3 pins are high, P select, P enable and P ready, then I can go for what? Access mode. Clear? So these are, to transaction is happened, 2 modes will be there. Right? One is setup mode and another one is access mode. To go with the access mode, before that I should do the handshaking. How to do the handshaking means what? Enable is equal to 1, period is equal to 1. And to select the slave, I should make what? Deselect is equal to 1. Did you understand? Then I can able to do the transaction. Accessing the data with the read operation or write operation. Now let us go with study about what is a controller. Many controllers. If you talk about keyboard, there will be what? Keyboard control. If you talk about USB pen drive, USB control. If you talk about other SD controller, SD card, there will be SD controller. What is this interrupt controller is? To understand this design of the interrupt controller, first we should understand what is interrupt controller overview, why interrupt is required, why we need interrupt controller, what external blocks does interrupt controller connect with, and interrupt controller detailed functionality, and the interrupt controller architecture, like how many interfaces and ports required with the directions, like input and output in output, what are the registers is required, what are the memory, whether registers are required, memory is required, does this require design requires any parameters. Okay, this is how you are doing, right? When you talk about FIFO or you talk about the memory, you are understanding all these parameters, overview, their requirement, we're using, why they are using, and any registers required, right? Memory is required, or parameter is required, whether it is a combinational design or it is sequential design. If it is sequential, okay, how many processes are there in this design? Okay, number of process indicating the number of what? Always blocks, correct? And then does the process requires any state machine? How many states are there? Then how each state will signifies, and then how to implement the code. And then we are list down the code algorithms. So these are the things is required to start with the one interrupt control. Now we'll see what is mean by interrupt control. Interrupt control. What is the interrupt controller is? If you take any complex SOC means system on change. The processor is a master here. So this is ARM. Here, whatever color, blue color you see, there is nothing but the processor, ARM-based processor it is. For any processor is a master, and the peripheral controllers are what? Slaves. What are the peripherals here? What are the peripherals here? You can see there is a keyboard, correct? Then CPI, RTC, UART, SSP, correct? This color, whatever this is gray color, you can see there are around 10 to 15 gray shades are here. All these are what? These are slaves. For any SOC, processor is a master and peripheral is a controller. Peripheral controllers are the slaves. If it's a slave, can initiate transaction to the master directly. Why? Slave cannot initiate a transaction to the master because transaction can be initiated by what? Master. Slave does not have it. What? Initiating to the master. So slave cannot transaction to the master because transaction can only be initiated by one master. What if slave wants to give some data to the master? Basically, understand complex SOP. Your SOC is nothing but processor. It is ARM-based processor, any other processors. Your processor is nothing but what? Master. All these are nothing but what? Peripherals is nothing but what? Slaves. Master can give the transaction to the what? Slave. But slave can give transaction to the what? Initiate to the what? Master. Did you understand? But if if slave wants to give some data to the master, what it has to do? Slave generates an interrupt to the what? You understand where the interrupt controller, what is the general meaning of the interrupt is? What is general meaning of the interrupt? Some sort of giving the disturbance, right? Disturbance. You're giving the disturbance. Or by giving disturbance, you are taking their attention. That is nothing but interrupt. In between, two people are talking, third person will comes and interrupt them means what? He's interrupting and taking their attention towards me. That is the meaning of interrupt. So what interrupt controller is required is, in the processor, in AOC, your processor is a master. Master can do the transaction to the what? Slave. But slave cannot directly initiate the transaction to the master. If slave wants to do some data, slave wants to give some data to the master, then slave is a what? Input. Now it has to interrupt the what? Slave wants to do what? Master. Master means what? Processor. Master means what? Processor. Now slave wants to interrupt the processor, master, to tell that I need your attention. To tell that I need your attention. So what is mean by interrupt is? Interrupt is a mechanism used by peripheral controller. Here peripheral controller means, I can call it as what? Slaves. Slaves to get the processor attention. Slaves to get the processor attention. Peripheral controller, example like USB controller or PCI controller, a DDR or keyboard or SPI controller, to get the attention of the what? Processor. Now the slave will be going with the what? Controllers. Interrupts controllers. You understand? To get the attention of the what? Master. Now we'll go for the what? We go for the what? Controllers, interrupts. If you want to interrupt the processor, I can go with the concept one, interrupts. Now see, your keyboard is directly, this is slave, keyboard is a slave. So the slave can directly do the instantiate to the what? Master? No, right? Do you understand what I want to do? I need to interrupt. First, I need to do the interrupt. Interrupt means to take this attention of this to the keyboard, I should go for what? Interrupt. I need to interrupt the what? Processor. Means master. So what is the analogy, interrupt controller analogy? If you talk in general, this is a classroom, right? So trainer and student and then admin. Your trainer is what? Master. Student is? Admin is? Interrupt. It is an interrupt control. Correct? Here. What is the job of the admin? Admin talks to both the what? Students and the trainers. Means master and the slaves. What is the role of the admin here? It is like interface between what? Processor and the peripheral control. It is an interface between the processor and the peripheral control, peripheral device. It may be keyboard, USB, etc. Any peripherals. Correct? So peripheral controls triggers the what? If I want to take the attention, if I want to send the data to the master, I can directly send it, right? What I want to do? I want to take the attention of the master processor. I need to interrupt it. So what I'm doing, peripheral controller triggers the interrupts. Students what? Interrupt the trigger the interrupts means what? Student raising the hand. Sir, I have a question. I should ask the question. This is nothing but one. Some sort of giving interrupt to the what? Trainer. So here these interrupts goes to the what? First, what it will do means these interrupts goes to the interrupt controller means admin. What will do? Admin will make a note of all these questions, and students who asked the questions, admin will note down all the questions. Now what admin will do? Means admin means here interrupt controller. Interrupt controller will forward those interrupts one by one. Right? If you collected the question, if you give all 10 questions at the same time, whether I can able to give, the trainer will able to give the answers. No, right? One by one. How he is doing one by one is nothing but based upon the priority. Okay, it is not first come first. One by one is priority basis. Priority basis. Now admin will give those questions to the trainer. One. Then what trainer will do? What trainer will do? Once you get the questions, processor will service the what? Request. Means trainer is answering the what? Student questions. The processor will get what? Processor will get the questions on what? Priority basis. One by one based on the priority basis. Now processor will service the request and trainer will answer the what? Student questions. It is a analogy, classroom analogy. Imagination of what could be the interrupt controller, what are the peripheral means slaves, what are the processes, correct? What is the job of the interrupt controller in the classroom analogy? What is the job of the admin is? You will take the what? Questions from the what? Students. Then you will keep what? According to the what? Priority wise. Then that priority wise questions are given to what? One by one to the trainer. What trainer will do? He will answer to the question. Then he is saying the trainer admin that I have answered the question. This student I have answered the question, he is giving the one. He is again giving the acknowledgement, like some sort of giving acknowledgement to the one trainer. So you are giving this priority. I have served that. They have completed that. Did you understand? This is what. So interrupt will forward those interrupts one by one to the processor on the priority basis. Admin will give those questions to the processor will serve the request. Trainer answering student questions. Processor will indicating to the interrupt, saying that what interrupt has been what serviced. Whatever you interrupted me, that service I have already done. Means give the question on the priority basis. I have answered that. I'm saying that I have answered. This is the one. Processor will indicating to the what? Processor will be indicating to the interrupt controller. See, this classroom knowledge is important to modeling the what? Interrupt control. You understand? So processor will indicating to the interrupt that interrupt has been solved. Then interrupt will be what? Drop means student dropping the hands. Student dropping the hand. So then what it will interrupt will now get the what? Next high priority. Next high priority active interrupt. So process will repeat. Process will repeat, right? Till all the active interrupts are what? Solved. That means you are raising the hand, but you don't have a question. Is that I need to give the priority to you? I should categorize what? Only the active interrupts means what? Active priorities. Who are raising the hands, having a question, according to processes, processor will give the answer to the student and again saying that this is done. Service has done. Did you understand? So this will repeat, right? For all the what? All the active interrupts are served till all the questions are answered. Once all the interrupts are served, processor will resume its what? Regular task. I am doing some other task. Processor is doing some other task. Interrupt controller interrupts me. Based upon the priority, I have served it. Correct? Once I have done, I will going to focus on what? Other task. This is what. Once all the interrupts are solved, processor will resume its the regular task. Means trainer start teaching the subject once all the questions are answered. So this classroom analogy of this one is quite important to understanding the modeling of what? Interrupt control. Now you tell me, trainer means what? Processor or a master. Correct? Student means what? Means peripherals. Means slaves. Admin means what? What is the role of the admin? It is interface between the peripheral and the master. But what is the important task he will do? He will collect the questions who are raising the hands, correct? He will collect the one by one, he will collect the questions. And then once he collect the questions, he will see which one is having a higher priority. Correct? Which one is having higher priority. Based upon that will be given to the what? Trainer. So trainer will address that. He will answer that question. Right? And he's saying that for that mean, so this priority you have given me, I have done that. Did you understand? Is it clear? Suppose there is no priority is there. Then now that the interrupt controller is giving admin is giving questions to the trainer. There is no priority is there. Correct? If there is no priority, how admin is giving question to the trainer processor? Then it comes what? First come first basic service, correct? First come first service. What giving? You are asking first question. First, the importance is given to the one who are asking the first. If there is a parity is there, so this question will be having higher parity. This is a very important question. 10 people are raising hands. Okay, he is collecting the questions. 10th person question is very very important. So we are giving parity to the what? 10th person. After that, we will see next question. Like that, we will give the parity words. Are you understanding? If you relating this same to this one, let us show you this one. This is what we are going to do. This is a black box. What you are seeing is this is nothing but your interrupt controller. Right? What interrupt controller will do? These are the peripheral interface, correct? Peripheral controllers. Like one is pen drive or keyboard, pen drive, SD card, peripherals. What it will do? It collects it. Correct? So interrupt active. It is going to collecting all the questions, like it is collecting the questions. And then what it will do? After collecting, you need a register, right? To give the parity. Parity registers is required. You will keep in this. That will be served to the what? Interrupt to the what? Service to this. It will give input to this processor. What processor will do? It will service through this. Interrupt will be serviced. Once this goes like this, then what it will do? You will say that completely service. Right? It will give the service and then it will give the interrupt this service to the what? Interrupt. Here, this is nothing but students. Peripheral means what? Students. This is nothing but what? Admin. This is nothing but what? Trainer. Are you understand? Here, processor is nothing but what? EVP. EVP. Processor means what? EVP protocol. So we will be using EVP protocol. So these priority registers are modeled by what? EVP protocol. In the interrupt controller, these priority registers will be modeled by what? EVP protocol. In this, correct? It will get the questions going to the trainer based upon the priority. Trainer will answer into these questions and then telling that it is serving. How do you understand? Now, did you understand why do we need interrupt controller? So, can you tell me why do we need interrupt? Interrupt to get the attention of one master or a processor. Through what? Through directly you can't initiate the from the slave to the master, right? Directly you can't do that. What you can do? You generate interrupt. Right? Interrupt. Now interrupt will be interrupting the what? Master or a processor and taking their attention. And then interrupt will generating the all priority basis. It is collecting all the information. Collecting information in the memory, right? Registers. Then it is serving to the what? Processor. Processor is addressing that one. Are you understand the classroom analogy? We understand that why do we need a interrupt control? The same thing what I explained here. So trainer means processor, admin means what? Interrupt controller, student means what? Peripherals. Questions means what? Interrupts. So as per the regular flow, trainer will teaching. When the student has a doubt, he is raising the hand, he's generating the interrupt. Keyboard controller got data from the what? Keyboard. So now it raises hand, what? Interrupt. Interrupt is collected by the what? Interrupt controller means admin setting the what? Sitting next to the trainer, and admin will collect all the questions means what? Collecting the interrupts. Figure out which is highest priority among all the questions. So based on priority basis, you can do the collecting of the question and giving to the admin round robin basis or priority basis or first come first base service. Now we saw that what is priority basis. If keyboard is having highest priority, then your USB or your SD card priority is going to what? Keyboard. USB. USB having highest priority. Let us take USB having 10 priority. Your SD card will be having 9 priority. Your other peripheral will be having 2, 1, etc. Then priorities goes to 1, which is having highest priority. Correct? Collecting the question and giving can be done what? Priority basis and then what round robin basis is. What is round robin basis is? The round robin basis is, suppose this is a USB, first year USB, okay? Then you are doing a SD card, then you are using suppose HDMI card, okay? Again this will repeat. First it will give the USB, then go to what? SD, then you go what? HDMI, again this will repeat. This is nothing but what basis it is? Round robin basis. But in our program, we'll be going with what? We'll be writing a logic part which is having highest priority basis. Right? If there is no priority, what basis I can do? Round robin also not there. First come first base service. Are you understand this? So admin will give the numbers, right? Numbers means what? Student name and number to the trainer. So interrupt gives the peripheral numbers to the what? Processor. The trainer means processor will address the questions for the interrupts. Questions has been answered. Student will drop the handing down in the what? Interrupt by making what? Making interrupt visible. So this process continues till all the questions means interrupts has been answered means served. Once all questions are answered, trainer will continue with the normal teaching. So with this, what is an interrupt is? It is a mechanism for peripheral controller to get the processor attention. How do you understand? A mechanism for peripheral controller to get the processor attention, that is nothing but interrupt. Why do we need an interrupt controller? Why do we need interrupt controller? Without interrupt controller, there is a chance of what? Losing or dropping of the what? Interrupts. Processor functionality will get what? It complex because without interrupt controller, processor will not have to do work for the what? Interrupt controller. Did you understand? Example, without admin, trainer will have not to do what?
हाँ आ गया
Admin work.
कितने
So
रहते हैं
interrupt makes sure that
हैं
it collects all the
हाँ ठीक
interrupts,
है आ गया
give them to the what? Processor one by one, so that interrupts are handled by proper order without losing of the what? Dropping of the interrupts. It also take care about the what? Interrupt priority. So what external box does interrupt controller connect with? What are the external blocks where the interrupt controller is connected with? One with the processor, one with the what? Peripheral controllers. Correct? Example, keyboard is what? Keyboard controller is. Memory controller is. USB controller is what? Peripheral. So interrupt controller detailed functionality, this will be discussed here. Right? Now, this you can look at this, you can easily analyze what is the interrupt controller. Correct? Now we are going to write the verilog program for this black box. Interrupt controller. Some sort of interrupt controller is nothing but getting the attention of the master. If you are directly, without going to this, if I go like this, what happens? Losing of what interrupts. not able to properly answer the questions. If 10 students are asking the same time, I can't give the answer to 10 people at the same time, right? Then I can't able to concentrate to the question. So that what we can do, we go for the interrupt control. To model this interrupt controller, what are the interrupt controller interfaces is are? For interrupt controller, what are the interfaces are? One is the processor. One is processor. Another one is what? Peripherals. Did you understand? So this is where to model this parity register, we will go with what? ABB. We will be using ABB signals. Also, what we are using? Interrupt controller signals. Is this analogy? You got an idea? Why do we need an interrupt? What is meant by interrupt control? Okay. So if you look at this interrupt controller, how many interfaces and ports are there? Two interfaces. One is for what? Processor interface. Means AVP interface, on-chip protocol. Correct? Processor means what? On-chip, right? What are the protocol we use? That will be what? On-chip protocol. AVP is a on-chip protocol. AVP interface. And then another one is what? Peripheral interface. What are the peripheral interfaces? Like you can call keyboard, correct? USB, mouse, etc. Did you understand? Now, what is this interrupt to service 3 down to 0 means?
No.
Okay, to know this, the words we are using for this, for the interrupt controller, let us go back to here and you see what this interrupts. This is nothing but what interrupts, right? How many interrupts are there? 4 interrupts are there. Then what is this? Nothing but I can call. This is an interrupt active. Active is nothing but for this interrupt controller. This is input or output it is. I am getting the interrupts from the peripherals. This is input or output then? Input. These are the interrupts I am getting from the where? Peripherals. How many interrupts are there here? 4 interrupts are there. I can write 3 down to 0. If there are 15 are there, 16 are there, 15 down to 0. So that for this interrupt controller, this interrupt active, this is nothing but these are the interrupts I am getting means I am writing as an interrupt active. Interrupt active is the input or output for this? Input. Did you understand? Then what is another input for this is interrupt controller? What is another input is? Interrupt service is the input to this. Right? Master is giving what? Once this based upon the parity, it gives the question to the trainer. Trainer will answer to this and saying that this is served. The interrupt served input or output is input. The interrupt to service output. Interrupt to service is nothing but output. Are you understand? Now this is input or output. Input. This red is input or output. Output. This green color input or output. Input. Did you understand? Now this interrupt controller will be having how many interfaces? 2 interfaces. One is what? Processor interface. One is what? Peripheral interface. Now for the processor interface, is one is what? ABB interface. ABB interface. Another one is what? Interrupt to service. Correct? Interrupt to service. And one more input is nothing but input. Interrupt to value. I was not talking about the interrupt to value. Interrupt to value is interrupt value is equal to 1. I need to do what? Valid operation. We are using valid, right? When you talk about the Milley model and Morey model, valid is equal to 1. What we will do? Whatever the pattern we are running, we are doing the pattern detection. If valid is equal to 0, still input is coming. I am not doing what? Pattern detection. Similarly, the valid, interrupt valid is an output. So this will tell us that we serve for the what? Correct interrupt will be served or not. See here, interrupt to service 3 down to 0 is output. For the interrupt controller I'm talking about, output. Interrupt valid is output. Means only if the interrupt valid is 1, interrupt valid output is 1, interrupt to the service is output is what? Valid only. If it is 0, whatever this interrupt to service is nothing but what? Not valid. To understand, what is the use of this valid? The valid tells that only if the interrupt valid is 0 is 1, what you are considering. Whatever the services, interrupt to the service to the processor, this output should be what? Valid. If valid is 0, this output is not valid. That signifies the what? Valid. Understand this terminology. Is it clear? Now, processor will consider this signal only if the valid is 1. If valid is 1, then only this will what? Consider. If valid is 0, this is not considered. Which one? Interrupt to service. Interrupt to service. So interrupt service means what? This is an input or output to the interrupt controller. Input. Where will get from this? The processor. What it signifies? Interrupt has been what? Service. Question is answered. Did you understand? Now coming to the peripheral interface. Peripheral interface. For the interrupt active means what? Questions. Questions I am getting. Correct? Interrupt active is 15 down to 0 means how many questions? How many interrupts? 16. Interrupts coming from the what? Peripherals to the what? Interrupt controller. This one I am talking. This red line to the interrupt controller. Correct? This is interrupt active. Interrupt active means what? Interrupt questions are interrupts from the what? Peripheral device are questions from the what? Students. Did you understand this? Clear? Now this is input or output to this interrupt controller. Input. This is nothing but interrupt peripheral interface. This interrupt active is the input. Underscore I indicates input. Underscore 0 indicates output. Did you understand? Interrupts coming from the peripheral to the interrupt controller. If you look at this complete interrupt controller architecture, whether this interrupt controller requires any memory or a registers? Yes. For what? For what purpose? To do this parity registers. Right? Once I get the interrupt, I should keep which one is the highest parity, which one that I need to keep that. I need a what? Memory. Does design requires a register? Yes. For what? Required for programming the what? Interrupt parity. Understand? How many registers are there? How many registers are there? If there are 10 peripherals are there. 10 peripherals means what? 10 registers are required. Did you understand? This is how I can write memory modeling. Range 3 down to 0. 3 down to 0 means what? 4. So parity register of A, 9 down to 0. There are how many peripherals? 10 peripherals. 10 registers. What is the width of that is nothing but 3 down to 0 means 4. Correct? 3 down to 0 means parity values. Program values from what? 0 to 9. 9 down to 0 means what? Number of registers. What about this? There are 32 peripherals are there. 32 peripherals. How many registers are required? 32. What is the width of that is? 4 down to 0. Declaring the parity register array, how you can declare for this 32 peripherals? Parity register A, 31 down to 0. This is nothing but what? 4 down to 0. Now you tell me there are 20 peripherals are there. 20 peripherals there. Huh? Reds, 4 down to 0. priority register is 90 top to 0. There are 20 peripherals are there. Did you understand this? Does this, to model this interrupt controller, what do we need? I need resistance. How do you understand this? Like same thing what I explained in previous. To model this interrupt controller, understanding the core functionality of the what? Control. Now, if I talk about interrupt controller, can you imagine the structure of architecture of the what? Interrupt controller? Correct? I mean to say, if you could able to recognize, recall this diagram in your mind when I talk about what? Interrupt controller. Are you clear? So this is interrupt controller. Understanding of the core functionality of the interrupt controller. So what is analogy? Is nothing but priority register will be there. What is the use of this priority register? To store the interrupts based upon the priority. Let's say admin gets the 10 questions at the same time. He cannot give all 10 questions to the trainer at the same time. He will give one question at a time, correct? He will give once at a time. How does this admin decide about which question to give the first? Based on the priority. So he will do it on the student priority basis. So student who has highest priority, their question will be answered first. How does admin knows the student priority value? How admin knows that the student priority value? Trainer will okay. Student question take first. Students will take first. This student you take first. What admin will do? He will keep that in his mind. Means in memory. Mind means what? Memory. Like in brain he will keep. Here how we are keeping this in? Registers. In processor, brain is nothing but what? Memory, right? Recalling. How you are doing in chip? You need a register. Right? You need what? Registers to remember that. So here, how does admin knows the student priority values? Trainer will tell him the student priority values before the what? Class starts. Student 1 is 10, student 2 is 12, and student 3 is 5, and so on. What it will do? Admin will remember all these numbers in his brain. Right? Then interrupt controller has to remember the peripheral priority numbers. What it requires? So registers, right? Registers means priority registered. If there are 16 priority values, 15 down to 0. Right? When interrupt process interrupts, it will look at the priority register to figure out which one to process the first. But if the interrupt does not have priority register, I think already I said this, right? There is no priority register. What happens here? Interrupt does not know the order in which the interrupt should be given to the processor. Interrupt will be served in the what basis? First serve basis. Or you can go another one is non-priority basis or priority basis. Did you understand this? Is it memory is required? Memory, I'm talking about memory is required. To model the register, correct? Registers are required, correct? So interrupt does not need any data processing. Hence, no storage is required. To keep this priority, we need what? The registers are required. But interrupt does not need any data processing, hence no storage is required. Does the design require any parameter? If you imagine the intercontroller program you want to model, write it, that requires any parameters? Need parameters, like how many peripherals, number of peripherals. Based upon number of peripherals, you are finding out number of interrupts. Peripheral means what? Interrupts. Correct? Then when you are modeling the registers, priority registers, that entire size issue, width issue. Correct? So parameter like number of interrupts or number of peripherals. Is this design sequential or combination? Since the next state of design depends on the current state. Sequential design means what? What are the states of the interrupts? Controller will do. the states is? If you remember, interrupt controller, what are the states? If I am talking about interrupt controller states in the states, what is the finite state machine is nothing but any requirement you looking as a state diagram. Then you can design the state machine. State yes, sir. State where no interrupt is what? Active. No interrupt is active. Interrupt active means what? You can consider this as state. What? Active. State interrupt given to the what? Processor waiting for the what? Service means what is this state indicates? Interrupt I have given the interrupt to the what? Processor. And processor asks for the interrupt. Like, what is another state you can? Interrupt has encountered some unwanted behavior. When the unwanted behavior is? Error will comes, you can unwanted behavior in the what? Interrupt. Then you can make this as a what? Error. So can we talk in other states for the interrupt controller? This moving. This okay, you should think in other possible way. I want to check whether my checking of the interrupt controller operation, you can model the any other state it is required. For this, for the 4 states, state with no interrupt is what? Interrupt active. State with what? Interrupt given to the what? Processor and waiting for the what? Service. Waiting for the service. Did you understand? These are the states. So we'll be using the finite state machine to model the what? Interrupt control. So before that, we'll be modeling what? ADP protocol. Means memory modeling. Correct? And then we'll go for what? Interrupt control. So this is about interrupt controller. So what are the various possible states in the interrupt controller? I can say interrupt don't have any interrupt to process is a one state. Interrupt gets interrupt controller gets the interrupt is a one state. Interrupt provides the interrupt to the processor and wait for the what? To be serviced is one state. Error state, any unexpected behavior happen, it goes to what state? Errors. These are the states of what I can call interrupt control. Are you understanding this? So with this we'll be start going with the what? Writing a design file for the interrupt control. What is mean by interrupt? Why interrupt controller is required? What component interrupt controller is connected with? Correct? What is a priority based interrupt handling? What is a first come first based service handling? Why registers? Why interrupt requires the what? ABP interface. Processor programs registered through the what? ABP interface. Did you understand? So with this analogy of this, so we will be writing the program. So these are the states of the what? Interrupt control. What are the states is? This is nothing but no interrupt, no active. Then this is nothing but what? List down all the possible state and draw the what? Draw them as a circle. Then do all the possible state transitions for all the possible inputs. So then we'll get it as a FSM. We develop the verilog code on this FSM time. First is nothing but no interrupts, inactive interrupts. So once active interrupts will come, so these are active interrupts. Then this will be served to the one processor, and then waiting for the what? Served. Or you can combine these two states also in the same. Now we are writing two states here, one for what? Interrupt given to the processor. Then it is what? Waiting for the what? Service. So initial state, nothing is getting is remains what? No interrupt list. If interrupt active is not equal to 0. Not equal to 0 means what? It is 1 or greater than 1. If there are 15 peripherals are there, greater than 1, right? If there are 10 peripherals are there, whether I can write 10 is equal to or greater than or not equal to 0. No, right? I can write not equal to 0. If it is 0, what? No interrupts. If it not is equal to 0, there are interrupts. So that I can go to interrupt active. In the interrupt active, what happens? It is giving interrupt given to the processor. Again, service waiting for the server. Once it is done, what happens here? If interrupt is not equal to 0, again what happens here? It go to the interrupt active. If interrupt active is equal to 0, then it is no interrupt. These are possible states. Here it is taking the error state. Error state is not. If any what unwanted behavior, bad behavior is happening, then I should go to the what state? Error state. You understand? So with this, we are going to write the what? Verilog programming. And before going to that, we'll see in interrupt controller how many processes will be there. If you imagine, recall that diagram of the interrupt controller, how many processes will be there? 2 processes. What is one process is? Implement one process, the programming the raised. I can call this is the first process. Next, what we need to do? This works on what clock? Programming the register will be done by what? ABP, right? So I can use what? Work on the what clock? P clock. ABP clock. Always at what? Positive of the P clock. Yeah, I think the interrupt is nothing but what? Second clock. So we make work on the what? P clock. So each process became start. Only one always. 2 processes are there, but both are working on P clock. So that I can write what? One always clock. If you understand this. Okay. So with this, we'll do one thing. So we'll write a program. After understanding this, we'll take up this in the next session. We'll write the program for the interrupt controller the next session. We'll write the design file like how exactly you are doing for your